So welcome back. My name is Anthony Wyckoff on behalf of Embrace Tutoring and Educational Services Rapid. You can join us for the final evening. Feel free to, as I mentioned, to simply post any questions you may have within the chat feature or as well as within the comments section. I'd be happy to get back to you. Okay. Now, today we're going to be covering a multitude of different topics within the SAT mathematics section and how to target and approach those types of questions to make it a little bit easier for you guys as you're sort of interpreting the math problems and what is the best strategy moving forward. So first we're going to start with some of the percentages problems, then we're going to break it down and go into the algebraic expressions, then we'll do some literal equation problems, and then the questions will gradually get a little bit harder as we work through. So feel free at any point in time to simply let me know if you guys have individual questions, okay, as we're working through. So the first type of problem that we're going to cover is a percentage problem. And it says here, a customer paid $53 for a jacket after a 6% sales tax was added. What was the price of the jacket before the tax was added? Now, the question and really what you really want to pay attention to is the fact that it says, what was the price of the jacket before the sales tax was added? So this is actually referring to what you would call the original price. And the equation that you're going to want to recall in this and how we're going to set this up is that the paid price here is going to equal your original price times your any sort of like percentage tax that you have. And on the SAT, and just as a quick kind of FYI, on the SAT, when they do some sort of percentage increase or what they're going to refer to as a tax, so a tax they're going to label as a percentage increase, okay? So on the SAT, a tax for a percentage increase, they're going to refer to this as sort of somewhat of a tax or a compound, or they might use the other word being interest. And the way that you want to do this is you want to have 1 point something. So basically you're going to multiply by the original amount. So let's say original here, original amount of something, times, and then 1 being 100% of something. And this part here is your actual percentage increase. And in other words, let's pretend that I have something that is initially, let's say $100, right? And that's pretty easy to break down. But I have an 11% increase on that $100. On the SAT, what they would want you to do is to do 100 times 1.11 as you're going through. So the 1.11 is essentially what is symbolizing the 11% increase, right? What they don't want you to do, what would appear to be the long-winded way, would be if I do $100 plus my $100 times 0.11. So you would need to convert this to a decimal, right? As always, but that doesn't change anything because this is also converted to a decimal. But notice here, this is a little bit more of a more additional steps, right? Where it becomes a little bit more difficult. Instead, what they're going to look for is for you to account that this is accounting for the 100%. That's what the 1 here represents. It's 100% of it. And this is accounting for your percentage increase. That's what this is here. So what you're going to do is you're going to take your original amount, in this case, my example being 100 times 1.11, right? This being my 11% increase, and then this would give me an amount, right? And it's obviously going to be $111 because $11 is right an 11% of 100, right? So I purposely chose an easy amount to do it, kind of as I'm providing you an example. But let's pretend this wasn't like a really easy amount. Let's pretend it's like $67.50, or in this case, $53 or something of that nature, right? So what you're going to want to do is just simply remember that your percentage increase is going to go after the decimal. So it's going to be 1 point something. Conversely, if it is not a percentage increase, but instead, if it is a percentage decrease, let's pretend I have, in this case, it's not tax. Let's pretend I have a sale, or let's pretend they use the word discount. And what I'm going to do is I'm not going to multiply by after or over 100%. What I'm going to do is I'm going to multiply by my percentage remaining, okay? Multiply by my percentage remaining. And what they refer to is, let's pretend you have a 20% discount, okay? Then the percentage remaining is going to be 80%. So what you're going to multiply by then is going to be 0.80. And this is what you would see in some of the standard problems for percentages and as you're working through. And now let's go back to this problem so that way you have a better understanding. This is a customer paid $53 for a jacket after 6% sales tax was added. So it paid the price of $53. Its original price, we do not know because that's what it wants us to solve. What was the price of the jacket before the sales tax? And then the sales tax in this case, because it's a 6% tax, is going to be 1.06. So all I'm simply going to do in order to find my original price is just divide both sides by 1.06, right? I'm going to divide both sides by 1.06. And when this happens, I'm going to get my original price. So let's see here, quickly doing this and sort of plugging in the calculator to save a little bit of time. Let's go to where we are. And there we go. Okay, so we have 53 divided by 1.06, and it is $50. Yes, great. Okay, so $50 is what my answer is going to be in this instance. Okay. Now I'll change this problem slightly just so you can see what I mean by a discount, so that way it makes a little bit more sense to you. Let's pretend that I also have a discount for this book. Let's pretend this book has a discount of being, let's say, 10% off. Let's just assume it's 10% off if they pay in cash, right? Let's make it super easy. That's 10% off if they pay in cash. A customer paid $53, so the $53 would still be the same, right? And then this is going to equal, and this says, because this is what they paid overall. Now, granted, once again, I'm making these numbers up, so these answer choices are no longer very valid, right? So you can scratch this out. I just want you to understand kind of the concept of what's happening. You will have your original price. You're going to have your 0.06, right? But the other thing you have to account for is that now, because of the fact that I have a discount, you're also multiplying by 90% remaining, right? This is what accounts for the discount. So this is your percentage remaining after your discount, and that's what you want to say. So if I do this now, right, this is 1.06 divided, or 1.06 times 0.9, and this gives me 1.06 times 0.9 gives me, yes, so OP times 0.954, and then this equals $53. Now I'm going to divide both sides like I did previously by 0.9, 0.954. These divide, and now I have, and I've divided this side also by 0.9, oh my God, 0.954. There we go, 0.954. So 53 divided by 0.954, and this would give me, in this instance, my original price of the book would have been $55, right, and 56 cents approximately, right? That would have been my original price of the book. So just basically what I'm telling you is that if you have some sort of tax increase, be prepared to the fact that it's going to be 1 point something. You're going to multiply by 1 point something. If you have a percentage decrease on the SAT, be prepared that you're going to multiply by your percentage remaining, right? So this isn't 0.1, right? It's 0.9, because this is to symbolize the fact you have a discount. And as I previously mentioned, this problem, this is an extension of the problem. I basically just added on to the previous problem, right? So our original answer here was $50, but if I suddenly add a 10% discount, then the actual original amount would have been right around $55.56. Okay, so let's do another problem that sort of is similar to this, makes it a little bit easier. This says a piece of furniture listed at $145, okay, is offered an 8% discount during a sale. The store then offers an additional 5% discount for those customers who pay in cash, right? So discount, discount, initially listed at 145. This is your, whenever you see listed is offered, this is your original price. Okay. And then it says here, which of the expressions is equivalent to a customer paying in cash? So they want to know what is the paid. So the paid in this instance, and if I'm setting it up appropriately, it's going to be $145 times my first discount, which is an 8% discount. So I have 0.92, right? This is assuming I have my 8% discount, and then times my second discount, which is going to be 0.95, right? So this is to account for my second discount. So my answer in this case then is going to be D, right? As I work through this, right? So 145 times 0.92 times 0.95, and that's if I were to solve it, that's what my answer would be. If I did a tax, right? If I had some sort of tax that was associated, then that tax would come over here, and this would be like a 1 point something because of the fact that I'm getting taxed, right? It's like 1.06 most of the time, unless you live in Hawaii, right? which is really expensive. Or if you live in certain places that aren't any sales tax, then it's right, then it's negligible, and you don't necessarily have to worry about that. Okay, I hope this is making more sense to you in terms of how the SAT is really going to approach percentage problems. And then finally, as I go down to this one, says a book was on sale for 40% off its original price. 40% off means you have 0.60% remaining. Notice I'm always immediately converting it to the decimal form. If the sale price of the book was $18, so this is my sale price, what was the original price of the book? So this, my paid, then is $18. My original price, don't know, assume there's no sales tax, okay. So here's $18 times my original price times my 0.6, like this, because that is what my percentage is remaining after my discount, okay. So after my discount. This is assuming I have 40% off. That's where that's coming from. So I'm just going to divide both sides. So 18, right, divided by 0.6. This side over here divided by 0.6. And this will give me my original price of the book. These cancel. I get original price by itself. And I get 18 divided by 0.6 as such, and when I do that, 18 divided by 0.6, saving some time, I get $30. That's my original price of the book here. And then you can even do this in reverse, right? You can say, okay, well, $30 was my original price of the book, like this, and then you can just multiply this by your 0.6 here. My pen is all funky tonight. All right, so 0.6 here like this, and when you multiply these things together, you will end up getting 18, right? Like if you were to calculate it to say, how much would you pay if you had a 40% discount and the book was initially $30, right? What would you pay? You would pay, right, $18. So there's different ways of reversing these types of problems. But what the most important thing for you to understand is, going back to this equation here, is just whenever you see a percentage increase on the SAT, usually referring to like tax or interest or something of like populations, etc., then just make sure that you're putting it after the decimal. Whenever you have a percentage decrease on the SAT for whatever reason, usually it does come with a sale or a discount or the big words, then just make sure you're multiplying them by percentage remaining, right? These you generally get one or two of these questions on every test. They're pretty straightforward when you know how to tackle them. So I just want to make sure that you guys can sort of fill in the gaps, okay? All right, I'm going to do a couple, I would say, sort of quick tips in terms of how to tackle certain types of algebraic expressions problems that really aren't that hard, but they seem a little funky at first. So I want to make sure that you understand always the key concept of what do they give you, how do you solve it, and right, how do you make that connection. Now, in this type of problem for algebraic expressions, here it says in the equation above, which of the following is the possible value of x plus 1? What you want to always pay attention to is what is given, right? What is given, and what are they asking you to solve for? And if you can somehow draw that connection to what is given and how you're trying to solve. Notice this, and a huge recommendation, so you don't make little mistakes on test day, is circle the item you need to solve for. Circle the item you want to solve for. Because sometimes they'll sneak in like solve for x or solve for 3x. And you don't want to make a little mistake as you're going through. So here I notice I have x plus 1. Here I also notice I have x plus 1. It says then which of the following is a possible value of x plus 1? And you want the entire thing, right? So what some people might do, and not understanding you want the x and the 1 together, what some people might do is you might actually distribute, right? You might cross multiply this, and then I think everyone can sort of come to understand that this form becomes this form, okay, right, when I cross multiply. But what some people might do is they might FOIL this. And if they FOIL this, then what they fail to recognize is that this wants to come together, right? So there's no reason for you to FOIL that, because then you have to separate it back, right, to make it a factor. So don't FOIL. If you FOIL in this case, it's because you weren't thinking ahead in terms of, oh, well, I'm going to have to solve for all of this together anyway, so it's going to make it a little bit more difficult. Instead, combine these. Make this x plus 1 squared equals 2. And now, in order to remove the square, just simply do the square here, like take the radical. And now this goes away, and you get x plus 1 simplified by itself equals radical 2. So the reason why I'm showing you this problem, even though it's relatively, I would say, straightforward, is because you always want to be thinking about, and I hope this helps, right? And hit me with like a quick like if it does. You always want to be thinking about how to solve for the thing that they're asking you, right? What's the most advantageous strategy of going about and doing this? So in this case, you see that you could FOIL if you want to, but because of the fact that they want this together, instead, it's just much more simplistic and much more efficient to just solve for the radical as is. So B is, in this case, going to be your best answer, okay? All right, I'll show you a couple more that are like this and then some other tips to make it easier for you. Okay, so here it says the expression above can be written in the form of ay squared plus b, where a and b are constants. What is the value of a plus b? Now, what I notice is that my first I want to notice and rewrite my form ay squared plus b. Okay, this is my format. And they want to know what is a plus b. So if I skim up to my equation up here, I do see the fact that I have a y squared, like as I'm interpreting this. So basically, it looks realistically like all I'm going to do is simplify like terms. So I have 757,532 plus 100 y squared. Because of the fact that there's nothing in front of this and I'm not distributing anything, I'm just going to bring this out of my parenthesis. But on the other hand, I do have a 10 here, so I'm going to distribute my 10 to make this make it a little bit easier. And if I distribute my 10 to both of these, then what I'm going to end up getting is my 100 y squared minus my, let's see here, 10 times, yep, it's going to be 1100. And what I'm going to then get is I want to simplify my like terms, right, as I combine these. So these are not attached to the y squareds, right, my 1100 and my 7532. So 7532 minus my, hold on one moment. Okay, so 7532 minus 1100. Yep, okay, so there we go. So we have 6432, which is what I thought it was, just always double checking. And then now here I have my 100 y squared and my 100 y squared. Okay, so now I'm gonna have 200 y squared when I combine these two, okay? And now this looks as though this is going to be my a here for attached to my y squared. And it looks like my b is going to be my other value. And what it is asking me, let's always remember, you're not solving for a, you're not solving for b in this case. You always want to double check so you don't make a little mistake of what are they asking you to solve for, right? Notice I always circle the thing that they want me to ask to solve for, because they could say, what's the value of b? What's the value of a? What's the value of this? What's a multiple of this, right? So I don't make a careless mistake. I always go back up to the section that they want me to solve for. And this says a plus b. So a plus b in this case is going to be 6,632, right? If I add these together, right? If I take my 200 and I combine it here, it's going to be 6,632. And that should be my answer, all right? So interpreting this type of problem for what they're giving you and not making little mistakes. All right, let's do one more. So here I have absolute values, and absolute values can be a little funky, but it says if A and B are the solutions to the equations above, what is the value of A minus B, right? Always circle the thing that matters. All right, now whenever you do absolute values, the most important thing for you to understand is that the overall output of whatever absolute value, because technically the absolute value is the distance away from the number line as it's defined. So this then is, this essentially is going to be positive, right? It's always going to be positive in some case. And if this is going to be positive, then you have to do this in two different formats. You have to do like a 2x plus 1 equals 5. And then you want to switch it up and you want to make it 2x plus 1 equals negative 5. So if I have 2x plus 1 equals 5, I want to subtract 1 from both sides like this. And then I'm going to get 2x equals 4. And I'm going to get x equals 2. Okay? And I can plug this back in real quick just to make sure. So 2 times 2 is 4, plus 1 is 5. The absolute value of 5 is 5, right? That's good. And then on this side, I would simply subtract my minus 1s like this. And I would get 2x equals negative 6. And then I'm going to get x equals negative 3. Now, the question is, because you don't know which one is A and you don't know which one is B, right? The question is, how would you plug these in, right? How would you go about doing this? Because of the fact that you have an A minus B and you don't know which one is A and you technically don't know which one is B. The answer for this and what you want to do is the SAT is doing this on purpose, okay? And the reason that they probably can do this on purpose is because of the fact that it's an absolute value for this type of problem. So my advice would be to plug it in. Plug in both. And if you end up getting the same answer, then it's definitely right? So plug in both because of the fact that here you have an absolute value. So here's what we're going to do. We're going to plug in 2 and minus 3, and then we're going to plug in minus 3 and 2 like in reverse. So we're going to do 2 minus negative 3, and then we're going to do negative 3 minus 2, and I'm going to put absolute values on both, like this, okay? And I have 2 minus negative 3, which is going to be, this is going to become 5. Absolute value of positive 5, which is 5, so that works. And then here I have negative 3 minus 2, which does, this is absolute value of negative 5, right? Negative 3 minus 2 is negative 5. So then this actually is also 5, so both of these work, right, as you see it. So this does work in this instance, and as we're going through. All right, now I'm going to, let's see here. Yeah, okay, so five is definitely going to be your answer then as we're going through. So 5 is our answer. Also notice, quick tip, if you've been following the page and if you've been paying attention, that always the open-ended problems, right, it has to be a positive value. There's no radicals as we go through, meaning that you will not have this sign in your answer, right? This, you can't put this in your answer, and there's no pi, okay? Which this question doesn't call for or ask for, but either way, still makes it a little bit easier. The fact that it's a positive value is what it should be, right? It should be a positive value, okay? All right, let's go to some literal equation problems, because I'm going to show you a quick tip of kind of what to anticipate as you're doing a literal equation problem. And your quick tip is this. Now, as I mentioned, guys, we're sort of in our final hour countdown of SAT math, right, for the Embrace Tutoring course. So sincerely appreciate you guys for tuning in. But if there's certain types of questions you want me to cover, I'm trying to do maybe like 1 or 2 of each major topic, right, just as a general crash course. And we're going to get to quadratics in a moment. But if there's certain types of questions that you want me to cover, just let me know, and I'll make sure. Now, whenever you're doing what is called a literal equation problem, the easiest way to spot the fact that you have literal equations, honestly, is the fact that you have an equation up at the top. All of your choices here all represent like F equals, P equals, P equals, P equals, F equals, F equals, and you end in a question. It always says which of the following expresses the number of this in terms of that. So whenever you have this wording here, right, which of the following expresses this in terms of that, this is what we're referring to as a literal equations problem. And literal equations is just general math, right? It's just you're using properties of math in order to solve and isolate a variable. That's really you're trying to solve and isolate a designated variable. They'll tell you what to solve for. It's kind of probably very similar to your chemistry or physics, right? For what you've done in the past of like solve for, V1 or T1 when you're doing, gas law equations or something of the sort, or when you're doing like kinematics, right, in physics. It's very similar to that. In this case, what you want to pay attention to, and this is the reason why I wanted to do this problem, is that your question is asking you, it says R equals F over N plus F. And this seems odd because guess the thing they want you to solve for? They want you to solve for F, right? So the question is, how are you going to get F by itself if it's on both sides of the fraction? And the first thing you want to do is always, you want to remove the fraction. And the way you remove any fraction is you multiply by their reciprocal, okay? So the way that you're going to set this up is you're going to cross multiply this n plus f over here. And here's the reason why. You eventually want to get f on the same side, okay? That's your goal. Your goal is get f, right, on the same side, so that way you can get it alone, right? So that way you can probably factor. So your other major tip is whenever you have your designated variable not in the same place, you 9 out of 10 times will probably have to factor, okay? 9 out of 10 times. So be prepared mathematically that you're probably gonna have to set this up, so you're gonna have to factor in some way. And here's what I mean. I'm gonna multiply both sides by n plus f, right? And this becomes r times n plus f equals f. Now, I'm purposely going to distribute here, so I get Rn plus Rf equals f. Now, I want to get f on both sides, right? So I'm going to bring this over here. I'm going to subtract it. So this is going to become minus Rf, which over here becomes minus Rf, right? I hope you guys are sort of following what I'm putting down. So then I get Rn equals f minus Rf. Oh, minus Rf. Oh, there we go. Okay, so then I get n, or Rn equals f minus Rf. Now's the part where I want to factor. And if I factor here, I will get f by itself. And that's exactly what I'm going to do. So here, I'm going to get Rn equals f, and I'm going to factor this out, and I'm going to get 1 minus r, right? Whenever you factor something, think like the reverse of it, like what multiplied by that will actually give me that outcome. So what multiplied by f will give me rf, right? And then that is what goes inside of the parentheses as you're factoring. Now, right, as I want to solve for this, I'm going to get f by itself, right? That's my goal. I want to divide both sides by 1 minus r. So my overall answer here is going to be Rn divided by 1 minus r is going to equal f. I got f by itself, which was my goal, and I'm going to look down, and it looks as though it's going to be b, right? Rn 1 minus r. Other quick tip, just in terms of as you're doing literal equations. So my first quick tip was, whenever you have the designated variable of what you're trying to find in your numerator as well as your denominator, you almost always need to be prepared to factor, because your goal is to get them on the same side. So in order for you to do that, you're eventually going to have to move it out and factor it in some way. The other quick tip is that use the answer choices here as a guide to help you. So use your answers to essentially kind of encourage where you're going to be, like what you should expect to see inside of your answer choice. And what I mean by this is that I should not be thrown off when I see a 1, right? That 1 should help guide me as I'm going through, because every single answer choice has a 1 in common. So the moment that I get a 1, I should sort of be thinking, oh, okay, I'm on the right track, right? That's sort of a thing that you can use. So use the answers to help guide you as you're going through, okay? All right, great, awesome, guys. So let's go now to a slope problem that we haven't done yet, that some of you have asked for us to do. And for those of you that tuned in previously when we did the slope problems, always remember that for your slope problems, you want to be thinking about a few different things. The first is, what is y equals mx plus b? Because the line is going to be linear, which means it's going to kind of be like a straight line some way. Also pay attention to the fact that the slope is actually your m, right? That's what your slope is. You can also calculate your slope using what is called your rise over your run, which personally I probably do the most because of the fact that you use this, right? You use your rise over run when they give you a graph, okay? So use this method when given a graph, like a graph or a table of some sort, and you see a straight line. For all of these, you're going to see a straight line. The other instance is that you might have to use y2 minus y1 over x2 minus x1. Now, this method you're generally going to use when you have fractions. Okay, use when given fractions and coordinates. Okay. Now, the reason why I'm suggesting that you're probably going to have to use this method, y2 minus y1, and not your rise over run, is because of this. You can't necessarily count up and over really easily, right? In this aspect, that's probably not something that's going to work well for you in doing it this way. So instead, what I would probably advise is to use your y2 over minus your y1 over your x2 minus your x1. Now, here's the major question, right? And the reason why I want to do this problem is because now the question falls in, okay, I do want to do this. I do want to do this method. Now, which of these do I want to choose, right? I get to choose any of the 2 out of the 3. And your choice is honestly going to dictate how long you spend on this question, right? So don't make it harder on yourself. What I would encourage you to do is purposely choose 2 points with the same common denominator, right? So choose, because of the fact that I'm doing fractions, choose the same common denominator, right? Same common, right, denom. Because then you avoid the hassle of having to solve more than one thing. And here's what I'm referring to, all right? So take a quick screenshot of this if you need to. That way it makes it a little bit easier. The first thing is we have a straight line. We know that we're doing linear and we're doing slope. Second thing is we could do rise over run, but because of the fact that these are fractions, rise over run is going to be a little bit more challenging. Third thing is, given the fact that we have fractions and coordinates of what we're plugging in, we're probably going to then use y2 minus y1 over x2 minus x1. Fourth thing is, when I'm selecting my 2 coordinates, I'm probably just going to choose the common denominator to make my life a little bit easier. So let's do that. All right. So obviously, given my common denominator here with 3 over 5, and given my common denominator here with 27 over 5, these are the points that I'm going to use. I'm also purposely, if I'm reading my graph from left to right, these are my 2s, these are my 1s, right? As I'm reading from left to right in terms of my slope. You could reverse them technically, but we'll keep it easy. Okay. I would not advise reversing them. Okay. So here I have my y2 minus my y1 over my x2 minus my x1. All right, now my y2 here is going to be my 3/5. So here's my 3/5. And then my my y1 is my minus negative 27 over 5. Now remember, the minus was initially what was supposed to be there. The negative 27 over 5 is my actual data point. Okay. So, and now I have 9, which is my x2, right? That's this point here, minus my negative 6, right? Which was my x1. Now, hopefully you can do this rather quickly. Minus a negative is going to be a positive, right? I'm going to make both of these positive, so this is going to become 15. And the same thing here, minus my negative, so these are going to be positive, right? Just like these become positive. So this is going to become 30 over 5. You could simplify this if you'd like to. If you want to simplify it, it's totally fine. What I'm thinking is that I'm also doing this somewhat of a step ahead, where let's say I have 30 over 5, right? And I'm dividing by 15, right? But this is 15 over 1. What also happens, right, because it's divided by 15 here, is that this becomes flipped. So this becomes 30 over 5, like this, right? 3 plus 20, yep, 30 over 5. And then this becomes times my 1 over 15, like this, okay? So that's kind of what takes place. So you can do it either way. I'm probably gonna actually, so the reason I was doing this was to see if there was like an easier way, right? If it was gonna simplify it all. Here is gonna be 6/15. So my answer for this, I'm gonna simplify, is gonna be 6/15, which both of these then are also divisible by 3. So when I divide this by 3, I'm going to make this my my 2/5, right? So 2/5 should be my overall answer. Okay. The only reason I was doing it this way was to see if I can also sort of thinking ahead if I can cancel something out. But 2/5 is great. Now that's also going to be my answer choice. The big takeaway from this problem: the moment that they give you fractions, you're doing y2 minus y1 over x2 minus x1. The fact that I have a straight line, as you see here, means the fact that I'm doing a linear line. The fact that they ask me for slope is y equals mx plus b, right? Or in this case, y2 minus y1 over x2 minus x1. And choosing common denominators within my answers, right? Choosing common denominators within my coordinates to make my life a lot easier as I'm working through this. Because if I didn't choose these two coordinates, I would have to solve for the common denominator here of 5/2, which I don't want to do. Right? That's even more work. Makes it a little bit trickier, so I don't want to do that. All right. Let's go to some of the just generic exponents and radicals for things to cover and like what to expect. All right, so we haven't covered this problem yet, but it's actually fairly straightforward. And here's my major tip to you. Whenever it says which of the following is equivalent to this form here, and you look down at your answer choices and you see like radicals and such, because here's the other thing too. This is actually traditionally in a non-calculator section, but the way that you want to be able to do these types of problems is that you simply take this 9 here, and it could be a 9, it could be a 4, it could be a 16, it could be a 25, it could even be like, let's say a 27, right? And what you want to do is you want to simplify it further, okay? And what I mean by simplify is that you want to make this 9 become like a 3 to the power of 2. 4 becomes like a 2 to the power of 2. The 16 becomes a 4 to the power of 2, right? You guys are getting the idea. But by simplifying, this could actually be a 2 to the power of, right, whatever it is, and then, or it can be like a 4 to the power of 2, which could simplify further. 25 is 5 to the power of 2. 27 is 3 to the power of 3, right? So basically what I'm saying is simplify it further. So this 9 is not 9. Make this 9 a 3 to the power of 2. And here's the reason why, right? And this is the $1 million tip. Because now when you follow exponent rules, what you're going to notice is that this 2 here, when it's going to be multiplied, right? This 3 to the power of 2. Because remember, whenever you have an exponent to an exponent, you actually multiply the exponents. So 2 times 3/4, right? Now what's going to happen is that my 2 and my 3/4 like this will simplify. This becomes a 1 and this becomes a 2. And because these simplify, now what I'm given is 3/2, right? So this becomes a 3 to the power of a 3/2, which is a lot easier than a 9 to the 3/4, right? So this is what I'm working with now. And if I have this, one other quick tip is that the number here that's on the top inside of your numerator, this number is going to represent your actual inside exponent. So that's the number that's going to appear in your exponent here, right? That's what this is. That number there is the exponent. The bottom number, that's what dictates your radical. So that's what's going to go on the outside here. So this is what you should expect to see if it's not simplified. If it's not simplified, odds are though they're going to simplify it, right? And they're going to expect you to be able to simplify it too. So let's talk about that for a moment to make it a little bit easier, okay? As we're going through and kind of what to expect. Now, there's different ways of simplifying radicals and how you guys have probably learned this, but let me show you kind of one quick way and perhaps a way to think about it and make it a little bit easier. So here's the 3 to the power of 3, and here's the to the power of 2. When you're simplifying a radical, you want to think what times that number, right? Or that number times itself, right? In terms of groups. So because of the fact that I have a 3 here, this is 3 to the power of the first times 3 to the power of the first times 3 to the power of first, okay? And all of these are under a radical, and the 2 is on the outside here to represent what is the grouping, like what is the square root of these things. Now, because of the fact that I have a 2 here, these need to be taken out in groups of 2s. So I have to take them out as a 2 together, right? So these become 3 times itself is what the square root is. So now I can pull this out, and this becomes a 3 radical 3 because I have 1 left in here, right? This one stays, these go out, right? As it has been simplified, as it comes out, right? So how many of these can basically be simplified to come out? You can also do it, you can basically also do it in this way if you think about it from this sense, because your teachers might have shown you this as well, where you will have your 2 on the outside, you'll have your 3 radical 3, and you could do, sometimes it's easier for you to see it in the actual radical, like radical 3 times radical 3, like this, right? As I have this here, and if I can take 2 of these away, right, because of the fact that I'm doing it by 2, so 2 and 2, so this multiplies by itself, would actually become a 3, right? And then there's 1 remaining, so 3 radical 3. So like I said, visually, there's kind of multiple ways to do it. Regardless of whatever way you do it, you have to understand the square roots, right? And you have to understand that 3 times 3 is going to be equal to 3 squared, right? Conceptually, you need to understand that, right, as you're pulling these things out. So my answer is going to be 3 radical 3, which it appears as though it's going to be D, all right? Your main tip for this question, and so you don't get stuck on the SAT if you're ever faced with this type of question, is that when you have something that can be simplified, like when you have some sort of exponent that essentially can be simplified, simplify it. Take it further, right? Simplify it further. It's not a 9, make it a 3 to the power of 2. It's not a 16, make it a 4 to the power of 2, or make it a 2, I think, to the power of 4, right? 2 times 2 is 4. Times 2 is 8, yeah, times 2 is 16. So don't make it 16, right? Make it 2 to the power of 4 in that case. So simplify it further. That way, it makes it easier when you want to somehow get rid of the fraction here as you're multiplying. Because if you do exponent rules, remember, 3 to the power of 2 times the power of 3/4, you have to multiply these through. And if you multiply these through, it will simplify to give me 3 to the power of 3 over 2. Right, and that's nice, right? 2 times 3 is 6. 6 over 4 gives me 3 over 2, and that's where I'm getting that from. Okay, awesome. All right, other quick tip as we work through is whenever you see exponents, okay, here, like where if I have if x to the a squared over x to the b squared equals x to the 16, the moment they start throwing a bunch of exponents at you, and the moment, too, that they give you a plus b and an a minus b, first of all, whenever they give you like something plus something and something minus something, what you want to think of in the back of your mind is what you refer to as a difference of squares, which means you're gonna cancel out the middle term, right? That's what that's referring to. So when you FOIL this, you would cancel the middle term, and that's the reason why you probably won't see it inside of the actual, like here. So what I'm guessing is, right, if I read this question, if I'm interpreting it, because remember, everything is there for a purpose. It's not just there just because, that they gave you this a plus b equals 2 for a reason, and they gave you this a minus b, right? This is what they want you to solve for. So you need to figure out what is the relationship between these two things looking here. Well, if you remember, if x to the a squared over x to the b squared, right, equals x to the 16, you want to somehow get these into what I would say to be exponent rules. And here's the reason why. Given the fact that I have the same base here, right, if I have the same base, then I can play in exponent rules if I bring this b squared up, meaning that this becomes, because of the fact that I have the same base, this becomes x a squared minus b squared, right? Because of the fact that this now becomes a minus b squared because I'm flipping the sign of the fraction. And if I'm flipping the sign of the fraction, this becomes an x to the 16th. And now, because also that I have the same base, what I can actually do And this is also a part of logarithm rules, if I remember correctly. I can cancel out my bases. And if I cancel out my bases, now what I end up having, let's get rid of this section over here, right? Easier. Now what I end up having, bring this over here, is a squared minus b squared equals 16. Well, that's super helpful. And here's the reason why. There's no x inside of my answer choices, right? There's no x. There's also no b's and there's no a's. So I need to start figuring out ways of getting rid of those variables where it makes sense. My x's are now gone. And now all I have is a squared minus b squared equals 16. But here's what you want to think about. What is your relationship of a plus b and a minus b? If I were to actually FOIL this out, right, as such, if I were to take the time to FOIL this out, a times a gives me a squared, okay? A times minus b gives me minus ab. B times a gives me plus ab, right? And then b times minus b gives me minus b squared. Well, what would you know? That is what the difference of squares is. You're getting rid of your middle term. So this would simplify to become a squared minus b squared, which is, ta-da, exactly what I have. So if I break this apart to make this a plus b, right? Basically, if I'm factoring it, I just proved to you that it works, right? That's the only reason why I wrote it down. Now what I have is a plus b equals 2. So I get 2 times a minus b equals 16. And as always, what I want to do is I want to quickly skim back. What do they want me to solve for? Up. What would you know? A minus b. I want to keep this all together here. That's awesome, because now I'm just going to divide both sides by 2, and I'm going to get a minus b equals 8, and 8 is my answer. Done, right? So that's your quick tip. That's how you think about things on the SAT. And just a general recap of the things you want to start to like write down, the things you want to start to like think about when you see these types of problems is, first, whenever you see exponents, okay, let me erase this here, and I'll point it out to you very specifically. Whenever you see exponents, you need to immediately start thinking of exponent rules, okay? You need to start thinking of exponent rules, and because of the fact that these are a fraction in some way, be prepared to bring this up, okay? Because they have the same base. If they don't have the same base, they will, the SAT will give it to you in the same base, but if they don't have the same base, you normally find a way to get them to be in the same base. If, given the fact that these do have the same base, always be prepared to get them on the same fraction line, right? So this is going to then simplify to become x to a squared minus b squared. Now, the other major tip that I'm telling you is they're giving you this a plus b and a minus b for a reason, which means they want you to understand what is the difference of squares. And then that is how your a squared minus b squared is going to separate to become a plus b and a minus b. And then you can simply solve for your a minus b. So be prepared to understand, one, what is the difference of squares, right? Pay attention to like if you get like u squared minus t squared, or like two things together, right? Pay attention if you're getting like variables a squared minus b squared, a squared minus b squared. Pay attention if you're getting like x squared minus 1. Pay attention if you're getting x squared minus 9. Pay attention if you're getting x squared minus 16, right? Watch out for perfect squares. Watch out for variables with no middle term that you'll see here. This could also be like u squared minus t squared, which I've seen in other problems. And watch out for perfect squares. That is a huge indicator that you're going to use difference of squares on the SAT, okay? Right. And the ACT too, for that matter. All right, so here we are. Here's general radical rules 101, and then we're going to move on to the next major concept. So general radical rules says the expression x minus 2 and y 1/2 so here's what this question is really assessing. And because I skimmed down and I see all of my answer choices do have radicals inside of them, here's what you want to pay attention to, is that whenever inside of your radicals, let's pretend I have like x, and like I did before, here's my 3. I'll make this easier. Here is my x, and then here is my 2, and then here's my 3, okay? The top number, once again, is the number that goes inside of the exponent. The outside number is the bottom number, is the number that goes inside of the radical, all right? Now the same would be like, let's pretend this is like A over B over C or something like that. Then this would become my radical, and this is A to the B power to the C radical. Okay, so like this is the format that you basically want to follow to make it easier for you as you're solving through. This says the expression x minus 2, and I have y. So what I want to do, because these both have the same base, is I want to bring this x down, okay? And then I would end up getting, and if I separate this here, I'm going to get x squared, x 1/3. I don't know if I need to multiply these yet. That's what I'm going to think about first, looking at my answer choices. And I'm going to bring this y up here, right? That way I can cross the fraction bar, and this becomes a y to the first and a y 1/2. Now, if these x's are separated in my answer choices, which it looks like they are, right? Some of these x's are separated here, then I may not need to actually like multiply them, and actually what would happen is I would have to add them, because following exponent rules, whenever I do like, say, x squared times like x to 1/3, what you have to do is you have to add these then, like this, plus 1/3. So what I'm trying to think about in advance as I'm doing this type of problem is, as I'm setting this up, and this problem's pretty straightforward to be fair, but the way I'm telling you how I'm thinking about it is, do I need to solve for my common denominator and convert this to fractions? That's really what I'm asking and what I'm thinking. And I don't think I need to. And here's the reason why. Because this y is a y to the first. This 1/2 here just represents 2 radical y, right? Which some of my answer choices show. Like B shows that. So does C, so does D. So A's gone. My bottom one here is x squared, and my x to the 1/3 is my radical x with a 3 on the outside, right? Because that's where the 3 comes from. So D is my answer, right? So that's what this is gonna look like and break down to. Hardest part about this problem is just simply understanding how to do radicals. That's it. It's just how to essentially label radicals in terms of what is your exponent versus what is your radical. Remember, the top number here, which is your numerator, that becomes your exponent here, and the bottom number, which is your denominator, that is what becomes your radical. So as you're labeling these things and you're putting them in the positions they need to, that's all I'm doing. I also, something you want to pay attention to, and please feel free to ask questions as we're going through, I purposely crossed these fraction bars here to make these positive exponents. That's the reason why. I purposely put them on the sides they needed to be in order to make them positive exponents. All right. Awesome, guys. Hope this is helping. I know it's definitely kind of like a little bit of a crash course as we're going through. We're going to do 1 inequalities problem, 1 or 2 just recap polynomial division problems, and then we're going to move down to some of the quadratics. Okay. So the toughest part about inequalities problems, I'll be fair, is they're lengthy, right? That's the toughest part about inequalities. And inequalities essentially are understanding kind of your greater than, right, your less than values, or your greater than or equal to, right, your less than or equal to, other things. And it totally depends on the position of where these things are. So remember, if your values over here are, let's say, like with this side, right, the open side pointing to this, and let's just come up with a random number, let's say 100, okay? It means that this amount, your values are going to be greater than 100, okay? If your values are, let's say, greater than or equal to 100, then you're going to draw this little line here. That's what the greater than or equal to is going to signify. The words you want to pay attention to, though, the words they like to sneak in on the SAT are at least, see, some greater than and less than, obviously. At least is a big one. And if it says something like at least, then your amount, right, for what you're going to have on this side of the equation needs to be greater than or equal to 100, right? That's what at least is referring to. At least $100. I cannot be less than $100. So cannot be less, right? The other, here's the other term they'll sneak in. No more than. Okay, so they'll have at least, and then they'll have no more than. No more than is the reverse of this, which means you have your amount here. And now notice I'm leaving this empty on purpose because it can be any variable, it can be any amount. But no more than means it cannot go over $100. It can be equal to $100, but this amount must be less, right? It must be less than or equal to, whereas here it must be greater than or equal to. The two phrases that they use most often that are probably the hardest for certain students are at least and no more than. They don't usually say always greater than or less than. It's a little bit too transparent. So the way that you tackle any sort of inequalities problem, here it is. One, you realize there's a lot of text. You immediately skim down to your answer choices, okay, as you're doing it. And then as you're reading, what you want to get in the habit of doing is using process elimination to eliminate certain elements of your answer choices that don't make sense. Right? That's really all you're doing. If you get really, really good at this, you will answer the question by the time that you hit the question, right? By the time you hit that question mark, you'll be finished with it. Also, general word of advice. Almost for every single inequalities problem, the bottom part here is simply telling you what the X and the Y represent. It's almost always the same thing, right? Which of the following systems of inequalities describes X, the possible number of 50,000 policies, and Y, possible number of 100,000 policies that Roberto sold last month. So they almost are always defining what X and Y are. The top part is really your bread and butter. The top part is the part that you're going to really need to understand well in order to solve these problems, because you want to pay attention to the terminology, right? Of at least and no more than. All right, so let's do this. So here, Roberto is an insurance agent who sells two types of policies: a $50,000 policy, which we've already identified as X, and a $100,000 policy, which we've identified as Y, right, given the bottom. Last month, his goal was to sell at least 57 insurance policies, which normally I would put here, right? Or sorry, here. Normally I would put that at least, but then immediately as I was skimming, this is what I noticed. He did not meet his goal, right? So I see what they did. I sort of like tried to trip you up. So here, what I have as I'm doing my inequality is, and actually let me see if you guys have any quick questions as we go through. Nope, no questions so far. So, but feel free to ask as we go. All right, last month his goal was going to set at least 57 insurance policies while he did not hit his goal. So 57 is going to be kind of the total for all of the insurance policies altogether. And actually, to make this easier, I'm going to put 57 on this side. And the reason is I'm skimming down. It's always on the right for what you're noticing. So I'm going to purposely set this up so I don't make a careless mistake, right? So he wanted to sell at least 57 insurance policies. Last month, it was a goal to sell at least 57 insurance. While he didn't meet his goal, the total value of the policies was over. Okay, so he didn't meet his goal. So he did less than 57 insurance policies, okay? And we don't technically know what he did sell. So this is going to be the best way to do that. And then it says the last month, while he didn't meet his goal, the total value of the policies he sold was over, which means this is over $3 million. Okay, good for him. So here we have the total value of the policies. Now, what you also want to pay attention to, and what they're going to try to do, is trip you up with what is attached to the X and what is attached to the Y. Just label it accordingly for what you have. So the 50,000 policy is representative of the X. So it's going to be 50,000 X, right? Because this is referring to the number of 50,000 policies. Just make sure that they're labeled together. And it's going to be 100,000 Y, okay? So this is what the answer should look like as I'm interpreting this problem. It does say the possible number of 100,000 policies that Roberto sold, and I think that's it. So looking at some of the differences here, it seems like all of these equations are all added, which this is too, and it should be, right? It should be the sum. It appears as though, is it C? Right, I'm looking here to make sure I don't make a careless mistake. So my inequality should face this way, X, Y, yep, there you go. You'll notice in inequalities problems, you're just making sure that you don't slip up on something in terms of the position or the sign of the inequality, or as well as what the labels are. That's your biggest thing. Every once in a while, you will do inequalities in equations, systems of equations problem, which is a little bit trickier. So we'll try to fit one of those in, if possible. If not, we have tons of videos on those, but they do take a little bit more time, right? Where you actually have to solve for X or solve for Y as you plug them in and sort of solve through. All right. All right, awesome. So let's go to, see here, let's do this one. Nope. Nope. Okay, so we have covered how to do these types of questions in the past, but I want to make sure that you don't get this question wrong on actual test day. So my general hint to you is that whenever you see some sort of like dividing polynomial that you have here, and if you get stuck and if you don't remember how to do synthetic division, the one thing that I will tell you is you can plug in a number, and you can match that number to make sure that it works if you get stuck. If not, you can always do dividing actual, like the polynomial expressions, which both ways actually honestly work. But here, I'm going to purposely try to plug in a number so that way you remember the strategy of what I'm telling you. So the number that I'm going to plug in this case is going to be x equals 1. I'm going to plug this number first into here, and then I'm going to plug it into my answer choices here, like rationally, so that way it makes a little bit more sense. I'm going to do 1 squared minus 2 times 1 minus 5. This gives me 1 minus 2, which is negative 1 minus 5, which gives me negative 6. And then I get 1 minus 3, like this. 1 minus 3 is going to give me negative 2, which gives me 3 overall. Because of the fact that I have a positive 3, and both of these top numbers here are 1 minus something, I'm probably going to start with C and D first. If I remember correctly, the answer is actually going to be D. So we'll go right to that, and I'll show you what I mean by plugging it in. So I'm going to plug it into the bottom equation. And the thing that I'm looking for, the answer that I'm looking for, if I plug in a 1 here to my top, or if I plug in a 1 here, both of these answers should be 3. And that's how I know that they essentially are going to be equivalent. And that's the trick, right? So I'm plugging in a number if you get stuck with dividing polynomials on the actual test day. So here I have 1 plus 1, which is 2 minus 2 over 1 minus 3, and this gives me minus 2 over negative 2, which, yes, would give me 2 minus negative 1, which does become positive 1 like this. So 2 plus 1 is going to give me 3. So 3 is my answer. D is my answer. Moving on, right? All right. You can do it the other way. Once again, you can do it through like classical synthetic division, which I know that we've covered. But I want to make sure that if you get stuck on how to do that for test day, just remember to use the strategy of plugging in a number and then finding which of these is going to be the best equivalent value. Okay. All right. So let's go to a quick SOHCAHTOA problem you might see. Here it says in a right triangle, one angle measures x degrees where sine of x is 4 over 5. What is the cosine of x degrees? The moment that they tell you in a right triangle, draw the right triangle. The moment they tell you that, okay, to make it easier for you, just visualize the right triangle. The side opposite of the 90 degrees of my right triangle, this side is always going to be hypotenuse. The other two sides are going to just be referred to as your opposite and your adjacent. Now, and here's the trick. The opposite side, and the reason I'm telling you these terms is because we're talking about SOHCAHTOA. The opposite side is going to be defined as the side opposite of the angle of reference. So what I mean by this is that you have what is called SOHCAHTOA. Now, sine of that angle of reference is going to be your opposite over your hypotenuse. Cosine of that angle of reference is going to be the adjacent over the hypotenuse. And tan of that angle of reference is going to be your opposite over your adjacent. But always, always, always depends on what the angle of reference is. If I change the angle of reference, then I'm going to change essentially what I refer to as the opposite, and what I refer to as the hypotenuse. So let me give you a quick example. Let's say that this here is A, okay? And we'll make this one B, okay? And I'm just going to make this like X, and I'm going to make this Y, so you guys can see the general breakdown. If I wanted to say sine of A, right, this is sine of A, that means that this becomes my opposite. My Y in this instance is my opposite, and my hypotenuse, luckily our hypotenuse is the only thing that always stays the same because it's across from 90 degrees. That is my hypotenuse. So this becomes Y over my hypotenuse in this instance, right? If I'm using this example as just like off the top of my head. Let's reverse it. Let's pretend I do sine of B, right? So if I do sine of B in this case, then my opposite is no longer going to be Y. My opposite is the other angle of reference, which, let's see here, we'll use green. Now if I'm going from B, this is my opposite side, right? This now becomes my opposite for B. So this is X over my hypotenuse. The hypotenuse, once again, stays the same, but my angle of reference here of what is the opposite. Now, here's the other thing. Okay, now you know how to figure out what is the opposite. Question is, how do you figure out what is the adjacent? The adjacent is simply the adjacent side, right, to that 90 degrees and to the opposite. So in this case, when I say sine of A, right, Y is going to be my opposite, and then X is going to be my adjacent, right? In this instance, X would be my adjacent. And reverse, if I do, let's say, sine of B, X is my opposite, and then Y is my adjacent in that instance. They both maintain the same hypotenuse. Now, so you sort of get the idea of how do you identify the opposite. When the moment they give you a sign of something, you immediately think SOHCAHTOA, okay? You immediately want to think SOHCAHTOA when the moment they give you some sort of sign of something. Now, here's the other thing. Now, and this, to be honest, this question is really not that hard. In terms of math, it's way harder in terms of like conceptually speaking. And here's the reason why I'm saying that. And I'll keep this here for you so you can see it. Let's pretend that I have my right triangle, okay? My right triangle here is the sine of X. So I'm just gonna make this side X, okay? That means that across from X, which is my opposite, this is a 4. Because this is my opposite. That's what the 4 is representing. It means that my 5 here, that's going to go on this side, this is going to be my hypotenuse. If you need to solve for the other side here, you could use Pythagorean's theorem, or you could, to save a bunch of time, remember it's a special right triangle, okay? It's a 3, 4, 5 special right triangle. If you need to, you definitely want to be familiar with a few special right triangles. They even give it to you in the section of the SAT within the reference section, right, to save you a little bit of time. If you need to solve for that. In this problem, though, you actually don't need to. And here's the reason why. Because, like, here's my X. Here's what they're asking you. And this is what makes the problem, like, harder conceptually. It says, what is the cosine of 90 minus X? Cosine of 90 minus X. Well, in every triangle, there's only 3 angles. There's an X, there's a 90 degrees, or in this case, there's angle 1, there's 90 degrees, and then there's angle 2, or, right? And the separate angle, angle 3, right? So they're angle 1, angle 2, 90 degrees. The question is asking you, though, what is the cosine if you remove the 90 and if you remove the X? So look at this. If I take out my 90 degrees, and if I take out, actually, I'll put it in red, right? Totally remove it. If I take out my 90 degrees, and if I take out my X, what's the only other angle remaining, right? so that's sort of what's funky about this question, is that this is the angle that they're referring to here, which in this case, then, let's just make this Y, right? In this instance, right? We'll just make it Y. So what they want to know is, and according to this problem, what they're really asking you is, what is the cosine of the other angle? And don't fall for this trap if they ask you on the actual test. This is a gimme, right? If they actually ask you on the test. Just 90 minus x, and the moment they tell you it's a right triangle, what they're trying to tell you is that it's the other angle that is really the point of reference of what they're asking. So in this case, they're talking about y. Now, if I were to erase this part here and erase this part here, right, just to kind of organize it a little bit. This is 3, this is 4, okay? What you want to pay attention to is my cosine of y now, right, going from this angle. This would have been my opposite, okay? This would have been my opposite, but what I'm asking for and what I'm looking for now, given the fact that I'm looking for cosine, remember, cosine here is adjacent. And what would you know? 4 is my adjacent, right? So the 4 still stays the same. And my hypotenuse still stays the same, right? So after all of that, after this whole thing, your answer is 4/5, right? Your total answer is 4/5. And hopefully you understand that your sine, and there's laws to this in terms of like complementary, or technically I think it's complementary angles of when two things are kind of together for the 90 degrees, right? The sine of one angle is going to be equivalent to the cosine of the other angle, right? Hopefully you remember part of those rules, but long story short, because they can ask this to you in a bunch of different ways, is the moment that they give you a right triangle, right? Just quick recap. The moment they give you a right triangle, draw the right triangle, understand, and the hardest part about this problem is just to understand the angle of reference here is what determines the opposite side, okay? It's sort of the vantage point of where it's looking. So what the angle of reference of what they're referring to is what will determine the opposite side. If I change my angle of reference to a different position, then I will have a different opposite, right? And therefore I will have a different adjacent. And let's go back to the green so you guys can see it. Go back to the green here. And here is my adjacent in this case, okay? So just pay attention to the way that it's gonna be set up. That's the easiest thing I can tell you, all right? All right, awesome.